Welcome everybody to History Analyzed. I'm your host, Mark Palmer. This is a podcast which examines historical events, issues, and people. The person we're analyzing today is Galileo Galilei. I love the fact that his last name was Galilei and his parents gave him a first name which was almost identical to their last name. They simply changed the last letter from I to O. Of course, most people just refer to him by his first name of Galileo. There are only a few people in history that are simply known by their first name. Napoleon, Michelangelo, Rembrandt, Dante, Galileo. At least those are the ones that come to mind for me. I know there are plenty of celebrities that like to go by their first names only, but let's see if they're remembered 400 years from now. There are a select few people who are known centuries after they are dead by only a first name. If you mention Napoleon, people don't ask you whether you mean Bonaparte or somebody else. That's when you know somebody was huge on the historical stage. So why is Galileo such a big deal? He is considered the father of modern science. So in this episode, we're going to discuss Galileo's impact on changing science from a system based upon reason, as set forth by Aristotle, to a system based upon experiments and observation. We are also going to discuss how Galileo proved that Copernicus was right, that the Earth is not the center of the universe, that we live in a heliocentric system with the sun at the center and the Earth is one of many objects revolving around the sun. And lastly, we're going to examine how Galileo's proof that the Copernican theory was right led him into direct conflict with the biggest science deniers of the 1600s, the Catholic Church. We'll go into Galileo's ordeal dealing with the Roman Inquisition and the terrible price he had to pay. But with any biography, we want to know when that person lived. Galileo was born on February 15, 1564, and died on January 8, 1642, at the age of 77 years old. He lived in various places throughout what is now Italy. But Italy was not a nation at that time. Italy did not become a unified country until 1861. And even at that point, the new country of Italy did not include the Papal States, which contained the city of Rome, or the region around Venice. Those two regions were added later. And in 1871, Rome became the capital of the fully unified country of Italy. You'll notice that I mentioned the Papal States. These were territories of central Italy that were ruled by the Pope from the year 756 until 1870. That's right, the Roman Catholic Church had its own country. Fun fact, today, Vatican City is still considered an independent country and is the smallest country in the world. It's less than 0.2 square miles or less than 0.5 square kilometers. On February 11, 1929, the Vatican signed the Lateran Treaty with the Italian government headed by Benito Mussolini. They each got something they wanted. Mussolini got legitimacy from the church, and Vatican City was formally recognized as a sovereign, independent state. Let's set the scene for what was going on in the world during Galileo's lifetime. In the early 1600s, the English colonies, which eventually became the United States, were being founded. The first permanent colony was Jamestown in what became Virginia in 1607. In 1620, the Pilgrims landed at Plymouth Rock in what eventually became Massachusetts. And 20 years later, the town where I was born, Greenwich, Connecticut, was founded in 1640, 2 years before Galileo died. Queen Elizabeth died in 1603, ending the Tudor dynasty. The Stuart dynasty began when James VI of Scotland became James I of England. You might not be familiar with him, but you're certainly familiar with his version of the Bible, which I'll explain later on. Earlier I told you that Galileo is considered the father of modern science. You don't have to take my word for it. Let's see what Albert Einstein said about Galileo. In a lecture given on June 10, 1933 at Oxford, Einstein said about Galileo, "Conclusions obtained by purely rational processes are, so far as reality is concerned, entirely empty." It was because he recognized this, and especially because he impressed it upon the scientific world, that Galileo became the father of modern physics and, in fact, of the whole of modern natural science. The reason why Einstein and most scientists consider Galileo the father of modern science is because Galileo introduced the scientific method. What do we mean by the scientific method? The scientific method is the manner of establishing facts through trials and experiments. It involves making an observation, forming a theory, making a prediction, and then conducting experiments to prove or disprove that theory, and finally, analyzing the results. So when Einstein said that conclusions obtained by purely rational processes are, so far as reality is concerned, entirely empty, he was talking about the state of science before Galileo. From the 300s BCE, Western civilization was relying on a lot of scientific theory that came from the Greek philosopher and scientist Aristotle. Aristotle did not use the scientific method I described a few moments ago. Aristotle primarily used observations and reason. An example would be that Aristotle believed that the earth did not move because of his observations. The earth did not feel like it was moving. There was not constant wind blowing across the earth in one direction, like if it was spinning. But this was not the scientific method that Galileo demonstrated and convinced other scientists to follow. So let's explore how Galileo used the scientific method for some huge discoveries. Galileo used the scientific method on pendulums. One of the big discoveries by Galileo was how pendulums work. This might not seem like a big deal, but it was. This led to breakthroughs by other scientists later on. And most importantly, Galileo's discovery of the laws of the pendulum led to accurate clocks. There are a lot of stories about Galileo that we don't know if they are true or myth. Some of these stories come from his biographers, but the origin of Galileo's pendulum studies supposedly came from him watching a lantern or chandelier swing back and forth. It seemed to him that no matter how far the chandelier swung, it always took the same amount of time. It gave him ideas, and he wondered if he was right. So, instead of just reasoning it in his head like Aristotle would do, Galileo conducted experiments. Galileo proved that the period of a pendulum is the same regardless of its displacement. Okay, it's time to go over pendulum vocabulary. A pendulum is a very simple apparatus comprised of only three parts. Number one, an overhead support. Number two, a string, which obviously could be a rope or chain, connected to the overhead support. Number three, an object at the end of the string. That object at the end of the string is called a bob. And now for a few other vocabulary terms. The period is how long it takes the pendulum to go from one side to the other and come back again. That motion is called oscillation. The displacement means how far the pendulum swings from dead center. Think of it this way. If you have a simple pendulum, like a round ball at the end of a rope or string, when it is still, it is hanging straight down. If you want it to swing, you pull it to one side. The number of degrees you pull it to one side from hanging straight down is the amount of displacement. We think that Galileo set up two identical pendulums, meaning the two pieces of string were the same length and the bobs at the end were the same size and the same weight. And before we go any further, I did look up to see what was the correct plural of pendulum, whether it was pendulums or pendula. Apparently, the preferred plural is pendulums, so that's the term I'm using. Anyway, Galileo pulled one of the pendulums a certain displacement, such as 10 degrees from vertical, and then pulled the other pendulum a greater displacement, such as 25 degrees from vertical. he let them go at the same time. Surprisingly, the period was the same for both pendulums. Even though the pendulum, which started out at 25 degrees from vertical, was traveling a greater distance than the other pendulum, they still took the same amount of time to complete a trip from one side to the other. In other words, the amount of time, which we define as the period, when you let go of the bob for the pendulum to swing to the far end and then come back to your hand. The size of the swing doesn't matter, the period is the same. This seems counterintuitive, yet it is correct. Galileo then examined whether changing the mass of the bob would alter the period. He took two pendulums with the same length of string, but on one pendulum the bob was much heavier than the other. Those two pendulums were released from the same displacement, meaning the same number of degrees from vertical. You would think that the much heavier bob would move faster, but it does not. The two pendulums had the same period, meaning the amount of time it took to swing back and forth, even though one pendulum had a much heavier bob. We're not sure, but we think that this is what led Galileo to his hypothesis that heavy objects and light objects fall at the same rate. I'm going to explain that in a little bit. Now, Galileo had to determine whether the length of the pendulum would matter. Galileo tested two pendulums that had the same size bob, and both were released from the same displacement, meaning the same number of degrees from vertical. The difference was the length of the pendulums, meaning the lengths of the strings. Galileo discovered that the shorter pendulum swung faster than the longer pendulum. The shorter pendulum had a shorter period, meaning the amount of time it took to complete a full trip back and forth. To sum up, Galileo discovered and proved that the mass, meaning the weight of the bob, did not change the period of the pendulum. He also discovered and proved that the displacement, meaning how far back you draw the pendulum before you let it go, did not change the period of the pendulum. But the one critical factor was the length of the pendulum. Pendulums of different lengths had different periods, meaning that it took longer pendulums more time to swing back and forth than shorter pendulums. All right, besides being very cool discoveries, did these laws of the pendulum have any practical applications? Galileo realized that the pendulum could be the basis for an accurate clock. Nowadays, we take accurate clocks and watches for granted. Not so in the early 1600s. There was no method of accurately measuring time when Galileo was conducting these experiments on the pendulum. Since Galileo proved that the oscillation of the pendulum was constant, what was now needed was a manner to keep the pendulum moving and to convert that movement into turning the hands on the face of a clock. In 1656, a Dutch physicist named Christian Huygens invented the first pendulum clock. This changed everything. Up until the 1930s, the pendulum clock was considered the most precise timekeeper. So yes, Galileo's experiments and calculations regarding the pendulum truly changed the world. These observations on motion fueled Galileo's curiosity about the movement of planets. Galileo considered the way the planets moved, but it was a German mathematician named Johannes Kepler that developed the laws for the orbits of planets. And then Newton and Einstein added to these laws. Anyway, according to the NASA website, Kepler's 3 laws describe how planets orbit the sun. They describe how, 1, planets move in elliptical orbits with the sun as a focus. 2, a planet covers the same area of space in the same amount of time, no matter where it is in its orbit. And 3, a planet's orbital period is proportional to the size of its orbit. I'll discuss Galileo's planetary observations later. Before I go any further, here's a little explanation of the origin of the term planet. According to the NASA website, planet was an ancient Greek word that meant wanderer. The Greeks and a lot of ancient peoples noticed that when they looked up at the sky, most of the stars seemed to be in fixed positions. Let me explain what I mean by fixed positions. Certainly, the stars move throughout the night. Look up at the stars. Then look a little later, and the stars appear to have moved across the sky. The ancients did not understand at that time that the stars moved through the sky at night because of the rotation of the earth. But the stars did not move in relation to each other. That's why, if you look at a constellation like the Big Dipper or the Southern Cross, for those of you south of the equator, those stars are in the same relationship to each other every single night. The entire Big Dipper or Southern Cross might move across the sky, but they stay in the same relationship to each other. The ancients discovered that there were some objects that seemed to move from night to night compared to the other stars. So one night you might look up and see the planet Mars in the constellation Gemini. At some other later night, you would look up and see that Mars now appears to be in the constellation of Cancer. The ancients discovered that there were 5 such wanderers or planets: Mercury, Venus, Mars, Jupiter, and Saturn. Those are the planets that can be seen with the naked eye. By the way, the planets appeared to move through the sky in the zodiac. What is the zodiac as far as astronomy is concerned? It's a belt-shaped region in the sky through which the sun, moon, and planets appear to move. At some point, ancient peoples divided the zodiac up into 12 constellations, which became the basis for astrology. I do not believe in astrology, but amazingly, some people think that the position of certain planets in certain constellations of the zodiac somehow affects their lives. Okay, new topic: falling objects. Before Galileo proved otherwise, people believed Aristotle's rule that heavier objects fall faster than lighter objects. Just using reason and intuition, this would seem to be true, but it's another example of why the scientific method is important. Galileo tested Aristotle's theory by dropping 2 objects of different weights and seeing if they fell at the same rate of speed. We don't know if it's true, but supposedly he conducted this experiment off of the Leaning Tower of Pisa. He was living in Pisa at the time. I certainly like to think that that's where he did his demonstration. Anyway, Galileo dropped 2 objects that were the same shape and material, so he would not have to account for wind resistance, but one was much heavier than the other. To the surprise of onlookers, the 2 objects hit the ground at the same time. By far, the coolest demonstration of Galileo being correct that all objects released together fall at the same rate regardless of mass occurred on the moon. Apollo 15 went to the moon in the summer of 1971. At the end of Apollo 15's last moonwalk, Commander David Scott recreated the Galileo experiment on live television. It was being broadcast back to Earth live. Commander David Scott held out a geologic hammer and a large feather from a falcon and dropped them at the same time from the same height. On Earth, wind resistance would affect the feather, but on the moon they were essentially in a vacuum and the hammer and feather fell at the same rate. He proved Galileo was right about the rate of falling objects. By the way, Apollo 15 was the first mission to use the lunar roving vehicle, commonly called the rover. If you've never seen it, look online for pictures or videos of the astronauts riding around in a very cool-looking all-terrain vehicle. Actually, 3 different lunar roving vehicles were used on the moon. One for Apollo 15, one for Apollo 16, and a different one for the last time human beings walked around on the moon during Apollo 17 in December 1972. Out of all of the human beings in history, there have only been 12 people who have actually walked on the moon. Neil Armstrong, Buzz Aldrin, Pete Conrad, Alan Bean, Alan Shepard, Edgar Mitchell, David Scott, James Irwin, John Young, Charles Duke, and the last 2 people to walk on the moon, Harrison Schmitt and Eugene Cernan with Apollo 17. Unfortunately, nobody has set foot on the moon since December 1972. Galileo is most famous for his discoveries in astronomy. Contrary to popular myth, Galileo did not invent the telescope. We're not actually sure who invented the telescope. Several men claim to have invented it. It seems most people give the credit to a Dutch lens maker named Hans Lippershey in 1608. But Galileo made his own telescopes, which were much better, and he put them to very good use. Most of his astronomical discoveries were contained in his book Sidereus Nuncius, which is Latin for starry messenger. That book was published in March 1610. Until Galileo investigated the moon with his telescope, people thought that the moon was smooth and featureless. This was mainly because Aristotle said so. Galileo told the world that the moon has craters, valleys, and mountains. He made accurate drawings and described the features of the moon, and some of those drawings were included in his Starry Messenger book. Before Galileo, people thought that the sun was a perfect celestial body which did not change. Galileo explained that this was not true when he discovered sunspots. What are sunspots? Well, according to the NASA website, sunspots are areas that appear dark on the surface of the sun. They appear dark because they are cooler than other parts of the sun's surface. As a kid, I learned how Galileo went blind by looking at the sun with his telescope. It's not true. Yes, Galileo went blind around the age of 72. Most experts now believe that he had a combination of cataracts and glaucoma, but it was not from looking at the sun. If he was looking at the sun with a telescope in the early 1600s, he would have gone blind then and not 25 or so years later. Galileo did not look directly at the sun with his telescope. He used a process called projection. Galileo pointed the telescope at the sun and, instead of looking through the telescope, he pointed the other end towards a blank sheet of paper. The telescope projected the sun's image onto that paper, kind of like a movie screen. By looking at the paper, he discovered sunspots. He noticed that the spots moved over periods of time, and by tracking the movements of the sunspots, he was the first one to figure out that this meant that the sun rotates on its axis. Before Galileo, people looked at the Milky Way and thought it was a cloudy band across the night sky. With his telescope, Galileo discovered that the Milky Way was a collection of countless individual stars. Galileo's most significant and controversial contribution to science was proving that Copernicus was right. Now we have to take a little side journey and discuss Copernicus. His real name was Mikołaj Kopernik. My apologies if I have a bad pronunciation, but I do not speak Polish. As an adult, he used the Latinized version of his name, Nicholas Copernicus. It was a custom of some scientists at that time to use a Latin version of their real names. Copernicus was born on February 19, 1473, in the town of Torun in what is now Poland. Copernicus is most famous for developing the heliocentric theory of the universe. He wasn't the first person to come up with this idea. The ancient Greek astronomer Aristarchus of Samos apparently first proposed the theory during the 3rd century BCE. Aristarchus of Samos did not work out the details of the heliocentric model, and he was not widely accepted. Copernicus is the one who explained the heliocentric theory and how it worked to Europe in the 1500s. So, what is the heliocentric theory? In simple terms, it means that the sun is at the center and the planets revolve around the sun. And most controversial of all was the claim that the Earth was one of the planets revolving around the sun. We don't know when Copernicus first developed his heliocentric system. We think it was sometime after the year 1500. But the Copernicus argument was controversial because most people in Europe accepted the geocentric concept of the universe. Geocentric meant that the Earth was stationary and at the center, and the sun, moon, other planets, and stars all revolved around the Earth. This was the doctrine developed by Aristotle and later refined by a Greek mathematician and astronomer named Claudius Ptolemy. Ptolemy lived in Alexandria, in modern-day Egypt, in the 2nd century CE. According to Ptolemy, the moon was closest to the Earth, then Mercury, then Venus, then the Sun, then Mars, then Jupiter, then Saturn, and then the fixed stars. All of these objects were revolving around the Earth, which was stationary and at the center of it all. So, for approximately 1400 years, most people in Europe were in agreement that the Earth was in the center and everything revolved around it. And here comes Copernicus saying no. In 1543, Copernicus printed his seminal work on the heliocentric theory. I do not speak Latin, and I apologize in advance for my pronunciation. The name of the book was De Revolutionibus Orbium Celestium. The English translation is On the Revolutions of the Heavenly Spheres. In that book, Copernicus presented the model that the sun was at the center, and then Mercury orbited around the sun, and then further out came Venus, then the Earth, then Mars, then Jupiter, and then Saturn. Those were the only planets known at the time. Uranus and Neptune would not be discovered until 1781 and 1846, respectively. Copernicus died on May 24, 1543. This means he died the same year as his book was printed. Since he died shortly after the book was published, Copernicus did not have to deal with all of the insanity and abuse from the Vatican or any of the other science deniers that Galileo later dealt with. How did Galileo prove that Copernicus was right? There were two main ways he proved the heliocentric model with his telescope. Number one, Galileo discovered 4 moons orbiting the planet Jupiter. We now know that Jupiter has at least 95 moons, but with his early version of the telescope, Galileo discovered the 4 largest moons going around Jupiter. And I am sure you're dying to know the names of those 4 moons. They are Io, Europa, Ganymede, and Callisto. According to Aristotle and Ptolemy, the Earth was stationary and everything revolved around the Earth. By showing that there were moons orbiting Jupiter, this clearly disproved the geocentric theory that everything in the sky revolved around the Earth. Number 2, the phases of Venus. A critical factor about Venus was known before the invention of the telescope. Venus always appears in our sky near the sun. When it is visible, Venus is the brightest object in the sky after the sun and the moon. You can only see Venus either right after sunset in the western sky or just before sunrise in the eastern sky. It was called the evening star and the morning star. At some point in the 500s BCE, the ancient Greek genius Pythagoras realized that the morning star and the evening star were the same object, the planet we now call Venus. And I'll bet right now you're thinking, the name Pythagoras sounds familiar. Well, he's most famous today for the Pythagorean theorem, which states the square of the hypotenuse of a right triangle is equal to the sum of the squares of the other 2 sides. By the way, something that drives math teachers like my wife crazy is a scene in the movie The Wizard of Oz. When the Scarecrow gets his diploma from the wizard, he misstates the Pythagorean theorem. In The Wizard of Oz, the Scarecrow says, the sum of the square roots of any 2 sides of an isosceles triangle is equal to the square root of the remaining side. Sorry, Scarecrow. The Pythagorean theorem applies to a right triangle, not an isosceles triangle, and deals with squares, not square roots. Getting back to Venus. Sometimes we see it after sunset, sometimes just before sunrise, and other times we cannot see Venus because it is too close to the sun from the Earth's perspective. Because of these factors, Ptolemy and Copernicus both agreed that Venus was between the Earth and the sun. But Galileo discovered other aspects of Venus. With his telescope, Galileo could see that Venus has phases like our moon. By phases, I mean, when you look at the moon, sometimes it's full, sometimes it's half, sometimes it's a crescent. Well, Galileo discovered the same phases for Venus. Through his telescope, Galileo could see on different nights that Venus started as a thin crescent. Then it would gradually wax over different nights until it became a full phase, meaning a complete disk, which we could call a full Venus, like a full moon. And then it would wane over different nights down to a crescent, and eventually it would disappear. According to Aristotle and Ptolemy, as well as the accepted theories of astronomy at the time, Venus was revolving around the Earth, and the Sun was also revolving around the Earth. But they thought the Sun was always farther from the Earth than Venus. How did the phases of Venus prove that Copernicus was right? It's because of the phases and another important discovery by Galileo. In addition to the phases, Venus changed in apparent size. It was smaller when Galileo could see it in its full phase, meaning a complete disk. And Venus appeared largest when it appeared as a crescent. In reality, Venus would appear to be largest when it's in its new phase, like a new moon. If you're not familiar with that term, that's when the moon is completely dark, meaning the illuminated half of the moon, or in this case Venus, is facing away from the Earth. Galileo could not see Venus in its new phase because it was between the Earth and the Sun. You were looking towards the Sun and could not see the planet Venus. Galileo understood that a full phase of Venus was smaller because it was on the opposite side of the Sun from the Earth. When Venus is on the far side of the Sun from the Earth, we are looking at Venus and seeing almost a completely illuminated disk, meaning a full phase, like a full moon. But because of the much greater distance, the full phase of Venus appears smaller. Galileo also understood that when Venus is closest to the Earth, it is between the Sun and the Earth. That's why we can only see a crescent Venus, because most of the half of Venus which is being illuminated is facing away from the Earth. So through his telescope, Venus appeared the largest when Galileo could see it as a crescent. The smaller and larger appearances of Venus, when the planet was either a full phase or a crescent phase, indicated that it was changing distance from the Earth. This meant that Venus was orbiting around the Sun, meaning Copernicus was right. Now let's talk about the Church versus Galileo. Why did the Vatican give Galileo such a hard time? And as I'll explain in a little bit, a hard time is a major understatement. They threatened to burn him at the stake. It's all because of the interpretation of the Bible in the 1600s. In this episode, when I reference any Bible passages, I am using the contemporary English version of the Bible. The contemporary English version is an accurate translation into modern English. People think that thousands of years ago, they used words like thou instead of you and goeth instead of go because that's the language in the King James Version of the Bible. Remember earlier when I said that during Galileo's lifetime, Queen Elizabeth I died and ended the Tudor dynasty, and King James VI of Scotland became King James I of England in 1603? Well, King James is the one who ordered the translation of the Bible into English. You always hear people talking about the King James Version of the Bible because it is the most famous English translation. The King James Bible was published in 1611. When people think of biblical passages, they think of the King James Version of the Bible. That's why they are using terms like thou and goeth, because that's just the way they were speaking in England in the early 1600s. People in the Middle East in biblical times were not speaking any form of English. Anyway, for clarity's sake, I will be using the contemporary English version of the Bible. One reason Galileo ran afoul of the Catholic Church was because of the Protestant Reformation. On October 31, 1517, Martin Luther famously posted his 95 Theses on the door of the church in Wittenberg in modern-day Germany. This set off the Protestant Reformation. Before that time, the Roman Catholic Church dominated most of Europe, but the Protestant Reformation split Christendom, and the Vatican became very touchy about any threats or even perceived threats to its authority. And I know that some of you are thinking, hey, what about the Eastern Orthodox Church? I'm not going into that because it doesn't relate to today's episode. Anyway, in response to the challenge to the Vatican's authority as a result of the Protestant Reformation, the Catholic Church called the Council of Trent in 1545. In English, we call it the Council of Trent, but that's just an anglicized version of the Italian town where it was held, called Trento. The purpose of the Council of Trent was for the Catholic Church to answer Protestant disputes. This covered many areas, including biblical canon, meaning what did the Catholic Church accept as the genuine interpretation of the Bible? In the Council of Trent, the Church took the position that only the Church could interpret the meaning of biblical passages, not individuals. There were two biblical passages which caused trouble for Galileo. The first one wasn't too big of a deal. The contemporary English version of Ecclesiastes chapter 1, verse 5 reads, "The sun comes up, the sun goes down. It hurries right back to where it started from." There was another Bible verse which really caused problems for Galileo. The contemporary English version of Joshua chapter 10, verses 12 through 13 reads, "The Lord was helping the Israelites defeat the Amorites that day. So about noon, Joshua prayed to the Lord loud enough for the Israelites to hear, 'Our Lord, make the sun stop in the sky over Gibeon, and the moon stand still over Ajalon Valley.' So the sun and the moon stopped and stood still until Israel defeated its enemies." This poem can be found in the book of Jashar. The sun stood still and didn't go down for about a whole day. This was the primary reason why the Vatican was opposed to Galileo's claim that he could prove that Copernicus was right about the heliocentric theory. The Church took the position that the biblical passages I just read to you were to be taken literally, meaning that God stopped the sun and the moon from moving at the request of Joshua so that the Israelites would have more hours of daylight to defeat their enemies. Galileo tried to explain that his position was that these biblical passages simply meant that God stopped the world from spinning, and it appeared that the sun and the moon stopped in the sky. The response from the Vatican is that the Council of Trent said he could not interpret the meaning of the Bible, only the Church could do so. Which brings up another argument by Galileo. Besides the fact that Galileo had scientific proof that Copernicus was right, Galileo also tried to argue to the powers in the Vatican that he was a very devout Catholic. And why was the Vatican siding with Aristotle and Ptolemy, who were both pagans? The geocentric theory says that the sun, the moon, and everything else is revolving around the earth, and that interpretation came from pagans. But the Vatican took the position that Galileo was reinterpreting scripture from the Bible, and that this was in violation of the rules set forth at the Council of Trent. Galileo argued that the Bible was correct, but nature and scientific observations and experiments are also correct. So Galileo argued that it wasn't God or the Bible that was wrong, it was human beings misinterpreting the Holy Scripture of the Bible. By the way, when I say that the Church said this and Galileo said that, it wasn't a direct confrontation yet. I'm just talking about their positions. Galileo wasn't put on trial by the Church until 1633. In 1615, Galileo wrote a letter to the Grand Duchess Christina of Tuscany. This was 18 years before he was hauled in front of the Inquisition of Rome, but this letter explains many of his positions with regard to his support of Copernicus and the heliocentric theory and any alleged heresy. In that letter, he stated, "It is necessary for the Bible, in order to be accommodated to the understanding of every man, to speak many things which appear to differ from the absolute truth so far as the bare meaning of the words is concerned." Basically, what Galileo was saying was that the Bible does not always speak literally, but uses metaphors and analogies. In that same letter to Grand Duchess Christina in 1615, Galileo goes on to say, "But nature, on the other hand, is inexorable and immutable. She never transgresses the laws imposed upon her, or cares a whit whether her abstruse reasons and methods of operation are understandable to men. For that reason, it appears that nothing physical which sense experience sets before our eyes, or which necessary demonstrations prove to us, ought to be called in question, much less condemned, upon the testimony of biblical passages which may have some different meaning beneath their words. What Galileo was essentially saying was that the Bible often used metaphors and analogies, but nature never does. So if there is a conflict between the words in the Bible and provable facts of nature, then we have to believe nature. Galileo was explaining that the two understandings of the universe, the scientific and the religious, are compatible, but the biblical text contained metaphors and were not to be taken literally. In that same letter, here is where Galileo states his main argument. In explanation and support of this opinion, they say that since theology is queen of all the sciences, she need not bend in any way to accommodate herself to the teachings of less worthy sciences which are subordinate to her. These others must rather be referred to her as their supreme empress, changing and altering their conclusions according to her statutes and decrees. They add further that if in the inferior sciences any conclusion should be taken as certain in virtue of demonstrations or experiences, while in the Bible another conclusion is found repugnant to this, then the professors of that science should themselves undertake to undo their proofs and discover the fallacies in their own experiences without bothering the theologians and exegetes. By the way, if you're not familiar with that term, exegetes, neither was I. I had to look it up. It means an expounder or textual interpreter, especially of Scripture. In plain language, Galileo argued that it was ridiculous to ignore what science could actually demonstrate was true. Although they did not use that term in those days, Galileo was essentially saying that the church was acting as science deniers. Galileo was not immediately hauled in front of the Inquisition in Rome. In 1616, Pope Paul V issued a decree that heliocentrism was heresy. As a result, Copernicus's book on the revolutions of the heavenly spheres was banned by the church. In that same year of 1616, Cardinal Robert Bellarmine warned Galileo that he was on dangerous ground. Galileo, claiming that he had proof that the earth revolved around the sun, was contrary to the position of the church and therefore heresy. What got Galileo in real trouble with the church was when he published a book in 1632 called Dialogo, with a long subtitle, Sopra il due massimi sistemi del mondo, Tolemaico e Copernicano, or in English, Dialogue Concerning the Two Chief World Systems, Ptolemaic and Copernican. Apparently, Galileo was told that he must present both sides of these scientific arguments. That is why he structured his book as a series of discussions. In the book, two philosophers are speaking to a layman. One philosopher is named Salviati, and that's clearly supposed to be Galileo. Salviati presents all of Galileo's arguments in favor of the Copernican heliocentric system, as well as several other scientific issues. The other philosopher, who argues against Galileo's positions, is named Simplicio. Galileo claimed that he named this character after Simplicius of Silica, a 6th century commentator on Aristotle. But most people thought he was just making a not too subtle dig at the people who argued against him, since the name Simplicio, spelled Simplicio, is very close to the Italian word semplice, spelled Semplice, which means simple, as in simple-minded. The members of the Roman Inquisition apparently took it that way and thought that Galileo was referring to them and all of those opposed to Galileo's scientific positions as being simple-minded. I personally think he was probably making fun of them using the double entendre. As I am sure you can guess, the character representing Galileo in the book comes across much better than Simplicio, who looks very foolish. The Inquisition was not amused. Galileo's book was banned, and that was the least of his problems with the church. On June 22, 1633, Galileo was put on trial at the headquarters of the Inquisition in Rome. He was charged with vehement suspicion of heresy. This was based upon his support and proof that Copernicus was right and we live in a heliocentric solar system. By the way, I know it's redundant to say heliocentric solar system, but I don't know how else to say it because we're not in a heliocentric universe or galaxy. It's just our solar system that revolves around the sun. Anyway, the 69-year-old father of modern science was now on trial. Galileo was threatened with torture, imprisonment, and even burning at the stake unless he recanted and admitted that the stationary Earth was the center of the universe, and the sun, moon, planets, and all the stars revolved around the Earth. I think most people understand why Galileo recanted all of his beliefs regarding the heliocentric theory. I hate when people say that he should have stuck to his principles and refused to say what the Inquisition demanded. That's easy to say when you are not facing those types of punishments. Just the torture alone would be enough for just about anybody to recant. In the 1600s, they really knew how to torture people. And being sent to prison was not like the prisons of today. I am not saying that modern prisons are not horrible places to be. I would never want to spend a single day in prison. I'm just saying that the prisons in the 1600s were much, much worse. And then let's think about burning at the stake. Being sentenced to death must be horrific, but being burned at the stake has to be one of the worst ways to go. I know some people claim that the Inquisition of Rome would not really burn them at the stake. Really? Check out what happened to Giordano Bruno. He was born in 1548 in Nola, a town near Naples in modern-day Italy. Bruno became a priest, but was later excommunicated because of his beliefs. The short version is that he rejected and ridiculed the supposed scientific laws set forth by Aristotle. Bruno wrote a lot about how Aristotle was wrong. He also had a lot of opinions on many other subjects that the church considered heresy. In 1592, Bruno was brought before the Inquisition in Venice because of heresy. The Inquisition of Rome demanded that Bruno be sent there. Giordano Bruno was placed on trial before the Inquisition in Rome. To be clear, he was not on trial simply for espousing the heliocentric theory, but also for many other supposedly heretical beliefs. Bruno refused to recant and was found guilty by the Inquisition under Pope Clement VIII. Of course, all of his writings were banned by the church. On February 17, in the year 1600, Giordano Bruno was brought out to the Campo dei Fiori, a square in Rome. He was stripped naked and tied to a stake. A metal plate was clamped over his tongue so he could not speak. And then he was burned alive. Talk about having the courage of your convictions. How many people would be willing to suffer such an excruciating death because they refused to state that they believed something that they knew was not true? So the people who think that Galileo should have spit in the face of the Inquisition and refused to recant things that he was able to prove are true are simply full of it. He knew that these were not idle threats from the Inquisition. Galileo knew what happened to Bruno only 33 years earlier. Since he recanted, Galileo was not burned at the stake or tortured or imprisoned, but he did receive punishment. He was placed under house arrest for the remainder of his life. He was also ordered to recite the 7 penitential psalms once a week for 3 years. In Galileo's book, Dialogue on the great world systems, Ptolemaic and Copernican, was banned. There is a legend that after Galileo recanted in front of the Inquisition, he muttered to himself, "Eppur si muove." That is spelled EPPUR space SI space MUOVE. And for those of you out there who do not speak any Italian, that means, "and yet it moves." Meaning that although he recanted and said that the earth was the center of the universe and stationary and everything revolved around the earth, he said to himself, "Eppur si muove," referring to the earth, and yet it moves. As much as I wish this was a true story, he most likely never said it. According to the historian Antonio Favaro, who wrote the seminal book Le Opere di Galileo Galilei, the works of Galileo Galilei, the earliest mention of the phrase "Eppur si muove" in print was in a book entitled The Italian Library by Giuseppe Baretti. That was published in London in 1757, 115 years after Galileo died. In that book, Baretti wrote, "This is the celebrated Galileo, who was in the Inquisition for 6 years and put to the torture for saying that the earth moved. The moment he was set at liberty, he looked up to the sky and down to the ground, and stamping with his foot in contemplative mood said, 'Eppur si muove,' that is, still it moves, meaning the earth." I don't think any historians take this account in Baretti's book seriously. We know that it's very inaccurate. Galileo was not imprisoned for 6 years and was not tortured by the Inquisition. And the book came out a century after Galileo's trial. It's hard to take it seriously as a credible source that this event ever occurred. In the early 1900s, people became excited because they thought there was actual proof that Galileo really said the famous phrase, "Eppur si muove." In 1911, a painting was discovered which depicts Galileo in prison, and he's pointing to the wall where he has used a nail to scratch a picture of the sun with the earth revolving around it, and underneath he has written, "Eppur si muove." It's actually spelled differently than the common spelling of the phrase, but close enough. It was claimed that the painting was from the artist Bartolomé Esteban Murillo and was painted in either 1643 or 1645, so within a year or 3 of Galileo's death in 1642. If true, then the painting could lend credence to Galileo saying the famous phrase. But most experts now say that it was not painted by Bartolomé Esteban Murillo. Most experts agree that the painting found in 1911 is a fake. It wasn't even an original painting. It was a copy of a painting from 1837 by the Flemish painter Roman Eugene van Mondegem. Sorry if I'm mispronouncing the name. That painting was over 200 years after Galileo's trial before the Roman Inquisition. All of it is very murky, but to sum it up, the only alleged evidence that Galileo said "Eppur si muove" comes from a book a century after his death and a painting made almost 200 years after his death. I would like to end this on a somewhat upbeat note. Pope John Paul II ordered a re-examination of Galileo's trial. In 1992, Galileo was officially acquitted by the Vatican, and Pope John Paul II formally apologized for the Galileo case. That was certainly a nice gesture, and I guess we have to say better late than never. That's it for today. Please subscribe to this podcast. Please like this and my other episodes. Reviews really help. If you are listening on Apple Podcasts, it's easy to do. Scroll down the History Analyzed show page, select a rating, hopefully 5 stars, and then tap Write a Review. If you're listening on Spotify or any other podcast app which allows ratings, I would greatly appreciate a 5-star rating. Please tell your friends, relatives, coworkers. Word of mouth is the best way to increase the audience for History Analyzed. Check out my website, historyanalyzed.com, where you will find links to fun items for history geeks. Thank you for listening. Catch you next episode.